I hope you understood the previous video that we plan to drive the relationship between the output, the voltage across C2 in this diagram, and our input OV. So I left the last part of the equation for you to do it yourself. But if you found it difficult or you want me to do it, so I'm just quickly showing how that is done. So I'm just going to rewrite this one here and simplify it to get to this point. So I have V over R1 minus R2 C2 divided by R1 dVc dt minus Vc R1 in one side, and in the other side I have C1 plus C2 multiplied in derivative of Vc over time, and then I have C1 R2 C2 second derivative of Vc over time. Now I'm just going to move everything to the right side and keep the V on one side, and then we want to kind of simplify it and ideally get the second derivative without any constant. So I'm going to divide everything with this word here that I have. Now let's move everything to the left, to the right, sorry. Moving everything except V, moving things to right side. So I will have V R1 is equal to, so when this one goes to the right, I can factor out the dVc over dt. So I will have dVc over dt, and then what we'll have is C1 plus C2, and this minus will be positive, so I will have R2 C2 divided by R1, and then I have this guy that goes the other side becomes positive, so it will be Vc R1, and then I have this one also left as it is, C1 R2 C2 second derivative of Vc over t. Now I kind of want to make this a little bit look better, so I will have dVc over dt. I will have 1 R1, and then I should multiply them, so you can write this as C or R1 over R1. So that's what I'm doing, because I want them to have a common bottom. Now C2 R1 plus R2 C2, and then Vc R1 stays as it is, and C1 R2 C2 second derivative stays as it is. Yeah. So well, I want to get rid of this word here, so I'm going to divide everything with that. All of them are going to be divided by, they're going to be divided by C1 R1 C2 divided by C1 R2 R2, C2, C1, R2, C2. So when I do that, I will have my V divided by R1, C1, this is 2, R1, C1, R2, C2, and then I will have my C1 R1 plus C2 R1 plus R2 C2 divided by R1 C1 R2 C2. It is a nice shape because I have all my constants together. Now I have my dVc dt, and then here that one divided with this one, they cancel each other, becomes 1. So I will have a clean looking second derivative of Vc dt, and that will be the final result for the relationship between the input and the output. So here, this guy here is my input, and here in the other side I missed one word here. Actually, one word is my Vc divided by R1, C1, R2, C2. Sorry. So I have my output here on its own, and also in first derivative and second derivative form. So this side is my output and this side is my input, and that's how we get the relationship between the input voltage supply and the output, or the voltage across the capacitor. Now in next video I'm going to explain another approach to get similar result, and for that we are going to look at the mesh analysis. This one was based on nodal analysis.